Have you ever wondered how you could test your circuits without blowing up transistors or using up your components? I show you how. Welcome back at Johnny's desk. Today let's make a simulation.
Are we real, or do we live in a simulation? And
although it seems interesting, I didn't mean this one. Of course, I am talking about LTSpice, the circuit simulator. With it, we can simulate circuits without destroying components. First, let's start the program. We have no project opened and can see the toolbar in the top. Create a new project by clicking on this symbol. Now we have an empty schematic. If we click here, we can find the included components library. We can also add external components, but this would be a thing for another video. Add a voltage source because you always need one. If we right click on it, we can edit the parameters. To show you more features, we need an example project. I thought we could talk about audio circuits a little bit. If we want to amplify an audio signal from, let's say, a guitar, we need an audio amplifier. It's the aim to get a louder output signal than the input signal. Without setting our parameters and values, we can start creating our circuit, because we can change all the values afterwards. Of course, we need an Opamp, so let's search for one in the library. If we open the library, we can see that there's a folder with op-amps. We could choose from a real existent operational amplifiers, but we go with the universal Opamp 2 and add it to our schematic. It needs a connection of the 12 volts and the ground line. Because we don't know the circuit we are making yet, we now have a search on the internet. I think we take this one, an inverting op-amp configuration. It amplifies the input signal by the ratio of RF and RI and inverts it. But we will see this in a few seconds. Now we must copy the circuit in our circuit simulator. I do this real quick. Normally I have two screens, or I divide my screen, so I see two windows at the same time. Now that I finished copying and typing the values, we can simulate the circuit. For simulating the circuit, you just have to click on the running symbol in the top toolbar. Then you get a prompt where you can choose the type of simulation you want to run, as well as the time and resolution settings. You can also get this menu in the far top toolbar under Simulate. For now, let's keep the transient simulation and look at 100 milliseconds. Later on, we will do an FFT frequency domain analysis too. Here we can see that a new window appeared. To see anything here, we have to measure a voltage, a current or a power. You can use a voltage or a current probe to get waveforms on the graph. For this, you move your mouse to the point you want to measure. If you can see the red probe, you are measuring voltage on a wire or a pin. If you can see the current probe symbol, you are measuring current. Just move your cursor to the right place. If you want to measure power, right-click with the Alt key pressed. We can even integrate over time by holding Ctrl and left-clicking on the graph name. I don't know why, but I can't record green. Oh, we have a lot of distortion, resulting in a near square wave signal. We can reduce the input resistor to reduce gain of the amplifier. Why don't we add real distortion to the circuit? We can do this with a diode clipping circuit. Of course, you would add a second inverting amplifier after this to recover the clipped output voltage. Maybe a buffer after this too. With this we have created a guitar pedal. Congratulations! I look forward to see what distortion designs you come up with. Tell me about it in the comments below. Like I said before, we can run an FFT analysis too. For this you just must choose the AC analysis as a simulation type. You must place the script on your schematic. To simulate a frequency sweep, a voltage source must be set to AC1. I just had to remember this here. We can see that our simulation result shows a frequency analysis of our preamplifier voltage gain. At low frequencies, amplification is low, and at high frequencies, amplification is higher at plus 14 dB. As usual for an audio amplifier. You could set the cutoff frequency with the input capacitor Ci. Electronics are really complicated and you have to know a whole lot, but as soon as you master the standard building blocks and techniques, you will be able to do exciting things. This was it for today. I hope you learned a little bit, and let's see next time at Johnny's desk. Bye. And next time let's see my Class E Tesla coil.